Welcome to this episode of Decarb Debrief. And I thought about doing this and I thought maybe I shouldn't, but here I am and we're going to go for it. Extra, extra. It's a Geo-Exchange extravaganza. I'm very excited to be here today with Jordan Gershberg. Thank you, Alex, for supporting that ridiculousness. And he is going to be going in depth about geo-exchange systems, which I'm really excited for. In the past, we have touched this ever so slightly in other presentations where we gave a brief overview, but there's a lot to know about this stuff. So I'm really excited to go through what geo-exchange is and what it isn't and talk about all the words that are floating out there. And I'm very thrilled that Jordan, you can be here with us today. So I'm excited because Jordan has done a wonderful job of starting in on some basics and then expanding to some more detailed things. So I think you will be in for a treat here. So now I'm going to stop talking as much and I'm going to introduce Jordan. Would you mind saying a few words about yourself, how long you've been at RMF, and how you found yourself getting into this geo-exchange stuff?
Yes. Thank you, Wendy, for setting all this up and heading up these decarb debriefs. I think we all benefit a lot from it. So hi, everybody. I'm Jordan Gershberg. I'm currently a project manager in the chilled water group and the infrastructure department in Baltimore. I'm actually what I've been heard as a boomerang. I worked at RMF back from 2011 to about 2017. Also in the chilled water group as a project engineer. Left for a couple years to go into a different category of work. I was working in the manufacturing field, mostly in food. And I decided to get out of manufacturing, go back into consulting engineering. And really, a lot of it is based on wanting to have these big projects that are furthering the future of energy use and deployment throughout our country. So that's where I'm coming from.
Well, I'm with you 100% on that. So I'm very excited for you to be here today. So I'm going to go ahead and share my screen and we can dive in to what we'll be chatting about today. So what we are going to be covering today is starting with that vocab. There are about 100 words that mean similar things or not quite the same things in this landscape. And a lot of it is because there's a lot of emerging technologies or new things to know about. And so Jordan has done a great job of like, let's talk about what words to focus on and all of the word soup that's out there. Then Jordan is going to be diving into Geo-Exchange specifically and how that works, because that is the most common implementation that we tend to do here at RMF. Yeah, I am excited for that part. And then, of course, as always, we leave time for Q&A so we can answer all of your questions. So with that, think I want to dive into some of this vocabulary. Jordan, you have a nice list here. Tell me what's on this list and why it made the cut for why we're going to talk about these things.
Yes, so there are a lot of different words, as Wendy was saying. Over time, we've developed a language that most people hear geothermal and they think anything that goes underground. But as we learn how to design, deploy, and really present these options to our clients so that they can get built, it's important to understand that they do mean different things. There are way more than what's on this list, but we're going to hit these high ones because they're what I've kind of heard as the most common interchanged words that really we as consulting engineers talking to clients who are considering these technologies have to be able to understand the difference between them and explain why they're all different. So
Yeah, I
let's
appreciate
jump
that.
right
And
in.
one thing that I'd love to add to that conversation is sometimes it's tricky because we want to use the scientifically correct term, and we'll go into that. But we also have to meet people where they're at. And geothermal tends to be what the greater world knows for anything. If they know anything at all, they may have heard of geothermal. Very few people I encounter on the street have even heard the word geo-exchange, and we'll talk about the difference between those in a minute. So one thing I want to counsel everyone as you learn today, I want you to think about how you can use use terms in practice as a way to set a standard without correcting people. I think, especially if someone is learning, you might want to just think about that approach. And we can talk about more of that later. But I wanted to just drop that in as a seed for a thought as we dive in here. So as we begin, let us talk about the term geothermal energy. Jordan, can you walk us through this idea?
Sure. There's a bit of a graphic on the right, which really identifies what the main difference is when we hear these different terms. So we're going to start with geothermal. Geothermal is a term that's been around for a long time. And at its heart, it is extracting the heat that is way down deep inside the earth under the ground. And so those are the two on the right where they talk about the deep wells as well as the one in the middle where it's really heat. You're pulling out the heat. You're pulling out the heat for a couple different reasons, where you're converting it into usable energy directly as heat that can actually make steam, and we'll talk a little bit more about that as well. Directly use the hot water, or use a heat pump to be able to capture and replenish that heat and store it for later. Now, that's not usually how the geothermal works. It's more on the extraction side where we're playing into this category in most of these new efforts or these past efforts where we are using the ground as a heat exchanger. That's really where the geo-exchange comes from. It's using the relatively stable temperature of the earth underground and its ability to either absorb or give off heat. We call that as a source or a sink. That's not terribly deep relative to how deep you would have to go for geothermal systems. And there's another term that's very common called a ground source heat exchanger. I like this term because it really brings in the idea of a geo-exchange system as a piece of equipment. In a lot of ways, we want to, in this industry, say, here's an air handler, here's what it'll do, here's a chiller, here's what it'll do. A geo-exchange system seems bigger than that because of how physically big it is. But in the end, it's really a piece of equipment that's just exchanging heat, whether as a source or a sink, to the ground.
I think that's really helpful because I think that part of the challenge of describing geo-exchange to any person on the street is that it is a system of things, but it is nothing without that ground source heat pump. So if you had to focus on just one thing, that's a really great piece of equipment that is the main component of it.
Well, I'll actually that was a perfect example, Wendy,
Yeah.
because it is
Yeah.
different. The ground source heat pump is
Mhm.
something we'll talk about, which
Yeah.
is a separate thing from the
Oh, I'm
ground
sorry, you
source
meant
heat
exchanger.
exchanger.
See,
Yeah,
here's
and,
the thing.
and that's
I
exactly
still
why
mess
we're
up
talking
on
about
this
this.
stuff, and I've been working on it so hard for the last couple of years. But even people that talk about this all day, every day, like me, still throw in a wrong word. So I'm going to use my gap as a teachable moment for all of you to be empathetic with yourself because this stuff can be hard. So thank you for the correction. I stand corrected. Let's move forward. But yes,
Uh,
that was me looking at the slide and being like, am I saying the right thing? And look and using that and not going with what I heard. So anyway, thank you for this. I think this chart is really helpful to talk about the difference between what we're talking about in terms of the depth of the system and the type of system. So this is a really great primer. So with that, let's dive a little bit more into this difference between geothermal versus geo-exchange.
Yep. So we have a couple of more practical pictures showing you what we have. So on the left, we have geothermal, and there's a couple of words that are up there right next to geothermal because there are some qualifiers as to the different types. You can have direct geothermal, you can have deep geothermal, and you can have enhanced geothermal. There's also a term that's engineered geothermal that we won't get too far into. And
I
I
want to
will
talk
want
to
to
the party.
let Wendy talk a little bit about the deep geothermal at Cornell,
Yeah,
is a unique situation as well.
sure. And we'll talk about that a little bit more in depth as we continue to go. But so I've been doing this thing. I've been listening to podcasts and it's been very interesting to me, but it's also been like, oh, now I don't know what to think. But there are even more words than are on this list. I heard the term super hot rock geothermal as a way to describe a deeper enhanced system, and I'm just like, I can't keep them all straight. So there could be another word that's thrown at you that you still don't know because it's a new way of describing something similar to this.
Yep.
But the other piece that I want to share is that Cornell campus is the only current higher ed campus in the nation that is attempting a geothermal system. And the reason for that is, I will say my bias is that Cornell is really cool and they have had lake source cooling, which is a very neat system ever since the 90s. And I honestly thought this was like Jurassic Park level. Should we be doing this kind of science? Like, why are we digging this deep into the earth? But we'll get to more of the reason why, I think, a little bit later. I think original geothermal was, let's use a resource that's really rare. So in Iceland, we have these volcanic pieces of geology. If we have a geyser, let's use that natural occurring phenomenon. If we don't have that, we can drill really deep into the Earth's surface to garner some heat. And that is a newer idea, but it is actually catching on because turns out petroleum industries are wanting some new business opportunities and they know how to frack and get that deep. So that's a little bit of a side comment. I'm going to turn it back to you, Jordan, before I take us down a million rabbit holes. Let's walk through this Geo-Exchange.
All correct. And where when he was getting at that top left, really it was dependent on your physical location on the earth, what access you had to those geological features. Geo-Exchange completely removes that need for a local deep geyser hot water source that's accessible relatively easily. And really, because the earth is where it is, we can dig under it and we can put in this system of pipes um, based on a bunch of math to determine what kind of heat exchange we're going to do. At the end of the day, you don't really see anything sticking up above. Here's just one example of one that's under a soccer field. But more words in the different types of geo-exchange. You can have the vertical fields, which is exemplified in this top right picture. You can have angle drilling, and then you can also do a horizontal where you're actually not going that deep, but still taking advantage of lengths of pipe, in a range of depths that doesn't necessarily have to go as far down into the earth.
Cool. Well, let's talk a little bit more, just dive a little bit deeper into the idea of the outputs of one versus the outputs of the other. Can you walk us through this idea?
Sure. And it's a really good way that I think we put this together because the output is what's actually coming out of the ground. In geothermal, you're directly extracting heat as steam or you're directly extracting heat as hot water. And then it's used as those direct use thermal utilities or through a heat exchanger to drive a turbine to generate electricity, again, utilizing those heat sources as a motive power to then to create other utilities necessary. In his way, it is a cogen system inherently. Um, Differently than that is the geo-exchange, and you'll notice the words that we use as the output of geo-exchange. It's extracted heat or rejected heat. It's heat that we are pulling out to make low temperature hot water or rejecting heat from chilled water condenser. Again, it is exchanging that heat two ways. There is heat coming out and heat going back in. And then it's used always with a ground source heat pump. And that will become much more prevalent in the conversation that we have ongoing because that heat pump is the key to being able to utilize electric energy to move the heat around in a beneficial way. And then we also, as part of that, can store that excess heat depending on the balance of heat load that the system is connected to.
Yeah. Yeah. So I definitely hear the source and sink words a lot with that. So, but I love that we're being more clear about where that source is from and where that sink is going to.
There are two more words that get thrown a lot around as you talk through this technology. There's boreholes and there's wells. A lot of times we say, oh, let's go drill some wells, and that's what we think we're talking about. But I wanted to give you that clarity where the borehole is a heat transfer mechanism. And most of the time when we're talking about it, it's through the physical process of conduction and convection with piping that has water or glycol flowing down through pipes that exchange or extract their heat from the ground. And those can be vertical or horizontal loops in the ground. The difference being wells, traditionally water wells, are where you are extracting water directly from an aquifer under the ground. And there are methods of geo-exchange that do use wells, but I think it's important that when we're talking about it, we do use the right term to say a closed loop with boreholes and piping, or it can call an open loop or an extraction loop with water wells where the water is actually directly coming up out of the ground.
I really appreciate you making this point because I have heard other engineers in shorthand say the term geothermal wells. And technically, a logical person who is educated could hear that term and think this kind of well for a true geothermal system, when what the intent of that engineer was to say, I'm talking about a geo-exchange borehole. So it's so common to have some of these shorthands because you hear it from other people, but to just be careful about what your actual meaning is when you throw around these words. Great point. Cool. Well, next I have a fun little thing for you. This is stay with me here. This is going to be really fun. Shout out to Nagar from our graphic design marketing team, the graphic designer on our marketing team for helping me build this. But what this is a core concept when we are describing a geo-exchange system to someone is the idea of heat recovery. And if a client doesn't understand that, it's really hard for them to understand how we can get more in depth about how a geo-exchange system actually works. So I like to tell this story to people because it is a way to draw them in. It uses an analogy to help break down some barriers when you're talking about something technical. So here it goes. Imagine, if you will, that you have an apartment. This is my adorable dog, Poe. The sun is shining in, and now Poe has gotten hot. And my husband, my darling husband, wants to turn on the AC unit because he secretly wants to be cool, but he says, look at the poor dog. And so I agree to let him turn on the AC as a sustainability queen. You know, I'm okay with it. Okay, we can turn it on. So once we do, cold air starts blowing onto Poe and he feels better. And he thinks, wow, isn't it so great that this AC unit produces cold? And I would say, oh, dear dog, that's so cute of you. But actually, an AC unit doesn't add cold to a space. What it does is it removes heat. So what's really happening is this. So, you know, when you feel cold air blowing on your face, it's really easy to think this AC unit is adding cold, but you would know that it's removing heat because if you walked outside on the other side of this thing, you'd be blasted with hot air from what is being extracted from the room and making you feel better. So the idea of heat recovery is saying, what if instead of literally throwing this heat out the window, we were able to repurpose it to where it's needed? And that is a really core concept to a geo-exchange system and the heat recovery that is part of it. So with that, why don't we dive a little bit deeper into a geo-exchange system? And Jordan, there's a lot of parts to this. It's not just the one thing as we were talking about before. Can you walk us through the components?
Sure. At its core, the box on the left with the heat pump and the hot or chilled water thermal distribution are the start of any conversation that might surround geo-exchange, because a geo-exchange field by itself is useless. It's just a bunch of holes in the ground. What you need, and most of our clients that are dealing with this have a building or a campus where they have heating and cooling demands. and it's coupling a thermal utility, pushing around hot water, chilled water in pipes, and connecting that to a side of a heat pump. Now, that alone is capable of generating thermal utilities we want. However, we want to have more energy efficiency and the ability to decouple the instantaneous needs of those heating and cooling systems. And so we would connect in the Geo-Exchange bore field as a heat source or heat sink. Now, there are some complexities and limitations of a Geo-Exchange bore field, which often necessitate the addition in the system of supplemental heating, especially as we work a lot in the northeastern United States where they're heating dominant. The bore fields are expensive, which we'll talk to in a minute, are also very large, which we'll also talk about. And so sometimes they just aren't big enough to do the entirety of what's needed. And so there is supplemental heating required as part of our commitment to serve the needs of the client under all conditions.
Great. I'm so glad that you walked through these components, Jordan, because I was just on that walk with my engineering nerd friend this morning that I just went on before this. We were just talking about the fact that no one really talks about how this is really the magic of the system. And then this is a cool extra as well, but this is a core component. So if we can be describing that to clients, that's going to be a really big game changer for us. All right, so let's talk a little bit more about the heat pump and what that looks like. So one thing that I really like to do is like, okay, can I imagine what this thing looks like in a campus plant? And so what you're seeing here on the left is these are the multi-stacks at Carleton College where they do have Geo-Exchange implemented. And they are cool. And when I'm looking at these things and staring at them when I was still learning, I was like, and what do? They do a lot of stuff. Can you walk through all of the things that they do?
Yeah, so heat pumps are really amazing and they're not new technology, but it's gotten a lot better. And it's gotten better from the control standpoint, being able to instantaneously adjust internally, as well as the refrigerants that are being used help it achieve these heat transfer mechanisms. Another piece is literally the culture surrounding it, is the understanding that we're not just going to make heat and burn stuff and exhaust a lot of that. And we're not just going to make chilled water and exhaust the heat that we pulled out, but the recognition that we can gain so much efficiency, COP of up to 7, with a single input being electricity, and being able to simultaneously move that heat around from your hot zone to your cold zone. Now, the good terminology that Wendy used as an add-on is to say, well, sometimes that load isn't going to be balanced. And so adding a ground source heat exchanger is very similar to having a cooling tower out in a traditional chilled water system. The difference being you're no longer just exhausting that heat to the atmosphere, never to be seen again. You're using the core, get it, the core of the earth there to act as a thermal battery to store some of that energy over time to be able to extract it again when you need it, when your thermal loads are more balanced for the equipment that you have connected. There are other things that you can add. You can do exhaust heat exchange. You can do solar thermal. You can extract from wastewater. You can do surface water. So there's other ways to achieve this same effect. Today, we're just mostly talking about the ground source heat exchange side.
That's great. And I love that you made the connection to the cooling tower because that just brings in your chilled water background. So that's really cool to hear your perspective on that. That's awesome. Cool. Let's look at this thing. I'm gonna level with you. The first time I saw a graphic like this, I wanted to cry because again, when I first was new, I didn't understand this concept, and now I do. So now I can walk through it. But it's important, all of you trained engineers, to see a schematic of how the equipment actually interacts with each other. So Jordan, can you walk us through that?
I can try. And initially, I'll be honest, I don't love this graphic. But I think
We're working
it,
on it. We're
it
working on a
being
hot
it,
topic.
it it's showing some complexity is a good talking point to how these systems are no longer standalone and how you have to consider heating when you're talking about chilled water, and you have to consider electric power, and you have to consider still natural gas and condensing boilers as that supplemental heating, depending on the size of your well. So all this is in there. There's lots of lines, there's lots of colors. The purple line is really, again, what we're focusing on today and how these heat pumps would interact with, there's the terminology there. Is it a well field? Is it a bore field? Even within our own language, we want to be a little more consistent.
Yep,
But the answer is it could be either one of those, depending on the unique geology and location of your client. Um, and if you thought that was confusing, go to the next slide. We had a sample of one of these where we designed a concept heat pump, heat recovery chiller plant. But what I wanted to explain from this slide is no one system across supplemental heating, thermal energy storage, heating water, chilled water, ground source, heat recovery, heat pumps, all of these things now have to be considered as a holistic system. And when you do that, you introduce some complexity in the controls and the operation that no longer is, turn on the chillers and we'll be okay. So didn't want anyone to really absorb this other than to really take into their minds that these systems, these previously disparate systems are now really trying to be connected to take advantage of that heat exchange across an entire campus.
absolutely. And I think this helps to demonstrate what we're up against when we are describing these systems to a mixed audience. It's a lot harder of an ask to understand a single piece of equipment versus a whole system. And so, and it's not something that we've had to do a lot in the past. So this is a new thing, and we'll give ourselves grace as we figure it out, but we're also trying to move the needle on it by having conversations like this. So let's talk a little bit about pros and cons of these systems of, why do a lot of campuses specifically want to take this on, but what are the challenges that they're up against with it?
Yeah, this is just a small selection of what we could talk about this. And, our master planning goes through this all the time, and there's lots of research. If you go Googling about Geo-Exchange, you'll see pluses and minuses. But these are, I think, the high level that are important for us to understand when we're talking about this with our clients. So a big pro of Geo-Exchange, it is disconnected from environmental temperature changes. It can operate any time of the year, and it can then operate any time of the day. So like thermal energy storage and a tank, it's a thermal energy opportunity for time rate electric charges to be able to reduce electric demand or reduce electric expenditure, depending on how you use it in your system. It also is a huge leap in efficiency because you're not just wasting part of your electric energy to the environment. You're storing it up as that thermal battery. As such, it can also reduce or eliminate the need for cooling towers. Now, cooling towers are a staple of chilled water system design and lots of other systems too, to reject heat to the atmosphere. But by using these Geo-Exchange system, you can repurpose some of that upfront cost and the high cost of maintaining cooling towers in both their upkeep and the water treatment needed for them. So their cooling towers, as a lot of you know, are usually open loop systems, which means the water in them is directly exposed to the air. They're great at cleaning the air, that is pulling all the junk in the air out, and then you got to deal with that as a system operator. Whereas Geo-Exchange is closed loop, so you really don't have that under most scenarios.
Great. Yeah.
Um, Wendy, I think you're going to say something there
Oh,
before
I
the last.
wanted to jump in. You used that phrase thermal battery, and I don't mean to take a whole side quest here for a moment, but I like that you did and that you said thermal battery. I think that when I've tried to describe Geo Exchange as it's like a battery to someone that's new to it, That usually doesn't go very well. And I'm going to say why is because people immediately think of a battery. The way that I was trying to connect it was saying it was storage, but most people think of, well, a battery gives you electricity. So then I've taken them down like a totally wrong rabbit hole as soon as I've started. So anyway, I just want to make a little side comment of like thermal battery. Yes, but preface with that thermal and you're golden. If you just say it's like a battery, you can start to take people down a path that you might not want them to. So that's my side
Good
comment.
point.
Yeah.
Yep, that's all part of educating about what these terms mean.
Yeah. Yeah.
And the last pro is a big one, especially, we're here under the topic of decarb. Um, Using a heat pump is inherently electric based, and it allows you to heat without buying or burning fuel. And that concept is really important because you're using a single energy input, electricity, and you're generating usable heat for your campus or your building, and you're not having a secondary input. You're not burning anything, you're not consuming anything other than the electricity needed to run the heat pump. And the circulating pumps, which is a big deal, and where that really plays out is the long-term operational costs of these systems. It dramatically can reduce those, again, based on electric rates, but you're not buying fuel.
Great.
So
Well, why
getting
don't you walk us through some bad stuff?
Yeah, so some bad stuff. It doesn't work everywhere. Sometimes you have geological formations under the site that you're looking for, or that you have, that just aren't going to be conducive to the boreholes in general or the quantity needed to make an effect for your campus. The usage is limited, and there's some terms that we'll get to in a minute: saturation, and controllability. But you do need some ability to balance the heating and cooling load annually. Um, just like a battery, if you have more energy than it takes to charge it, it's only going to charge so much. And then once it's depleted, you can't use any more. The thermal battery that is the ground works in a very similar way. So balancing those loads into it by how much energy you extract from the ground or put back into the ground over the course of the year really, really becomes important and adds to the control needs of your system. Big one, dollars. It costs a lot to drill all these holes. We'll talk a little bit more about that later, but it is generally the most expensive upfront option. With, always try and put in, but it saves on the long term, in both the energy efficiency as well as the decarb side. It's messy. You gotta dig a lot. When you drill a hole, even a 4-inch hole, that's a lot of volume of dirt and sludge and rock that then has to go somewhere. It's also noisy. The drill rigs can make a lot of noise, and you gotta dig down pretty deep before you even can get to the well. So a lot of disruption, during the install. Another thing is once it's in the ground, you have essentially blocked off a lot of that area from certain types of future construction. Really important to understand that in a campus context or anywhere that you're going to put this on, that there's a very clear understanding and documentation of where it's going, so that you recognize that land has pipes under it, and that's connected to another system, and you can't really take them out.
Yeah.
And then the last one is really critical, and we're still learning more about this daily, is what's the long-term availability and viability of these. Depending on how you're used, you may get to temperature saturation, and the pipe is usually HDPE, but that has a lifespan too. And once that is done, there's a big question of what do you do next? So those are some of the negatives of it.
Great. Cool. I want to just walk through this super quickly. This is just sort of harkening back. We've been talking about efficiency a few times during this talk already, but I just wanted to remind people of the range of coefficient of performance, which is a metric for how we're measuring that efficiency. And just draw your attention to the thing on the right is that simultaneous mode. And then Geo-Exchange is also a really solid COP, but it is half of that simultaneous mode. So that's why that multi-stack has those different modes of we want to be running at that 7.0 as much as we can, but then when we're out of balance, we're going to the very next best thing. So that's something I just wanted to re-emphasize as part of this talk, but not spend all the time on because we have to talk about some more cool stuff.
Yes, so this slide I like a lot, and we could have a whole presentation just on this one. I'm gonna be very high level here. When we do talk about Geo-Exchange, it's not just holes in the ground with water loops. There's lots of different ways that we can utilize that thermal battery of the ground. We can do it in what's called an extraction and recharge well, which is more of the well side where we are pulling out water, using it as a heat source or sink and putting it back in. So that's the leftmost and rightmost diagrams. That does really depend on your local geology. You got a pond loop. If you have a pond, that water again has the ability to exchange heat with the atmosphere, which the ground, and that can be different technologies, literal more things that we're familiar with in the view of a heat exchanger, often stainless steel panels that can go into the water, and those can go into shallow water or into deep water. Another really interesting one is what's called an energy pile, where when you're putting in usually tall buildings and you're sinking piers, you can actually put the tubing of the Geo-Exchange piping into those concrete piers. And then that itself becomes a long cylindrical heat exchanger. You can do ground loops of different types, horizontal, vertical, angled. And so what's important to take away from this slide is just when someone says Geo-Exchange, it's important to understand what they have available in the different construction modes of their system. So a lot more that could go into that, but I'm gonna kind of leave that one there. And if you have more questions, we can talk more about that.
Yeah, that's great. I think it's important to remember there's more than just boreholes. But I will say the most common thing we implement is a bore. So can you walk us through how we get started with that process?
Yeah, there's a lot to it, and knowing what's in the ground is akin to going and doing a site survey beforehand or getting load data. You have to know what you're dealing with underground, and oftentimes that involves going to take a test bore. Test bores for Geo-Exchange systems should be done by uh, experienced Geo-Exchange well diggers, well drillers, because it is different than just your local water well driller. Depending on the size and the complexity of the site, 2 to 4 or more test holes. And they have a lot of different equipment that can go in that pull out data over the depth of the system. The result of that is a formal test report, and I think one thing that is important is the analysis of that by a geotechnical engineer is critical. We, at the moment, most of us would have this long report and not necessarily be able to translate that into usable information to say, here's what this ground will do in terms of its capability of absorbing or releasing the heat that we need. And so kind of on the right is a little graph, depending on the types of soils, the soil formation, the pressures within, the depth to water. There's lots more that go along with that, other aquifers. You need different equipment. This is why a qualified well driller is really important in these early stages of getting a test bore, because different rigs, different pumps, different tools, even different bit selection make a big difference into what you can get out of the ground. For anyone has done a lot, any sort of digging or test pitting, they have, bore refuser, auger refusal. That is to say, it just won't go down anymore. Well, that may just be because they have the wrong equipment on site.
Mm.
And this is not cheap. in order if you're doing this, you're committing some serious capital to understanding what's going to go under the ground to know whether or not you even can have a geo-exchange field. And right now we're carrying in the range of about 50,000 per bore hole in the testing phase even. Talk a little bit more about pricing, but that's on the order that you're going to get for a couple of different reasons. Some interesting things that we learned at the International Ground Source Heat Pump Conference was a piece of the reason why these are so expensive is supply and demand. There just aren't that many physical drilling rigs and people that know how to use them to get out and hit the demand of all these going on. So that's just market forces driving up the cost for an in-demand service.
Okay, we got to pick things up here, Jordan. We only have a few minutes left before Q&A, so let's talk quickly through the different kinds of bore fields and the ways that we can drill them.
Yeah, here's a couple of pictures just showing how much disruption can really be caused. These boreholes can be 500 to 1,000 feet deep, 4 or 6 inch wide holes. To be able to connect all the various bores across a field together, they have these headers that they call laterals that will connect them usually in a reverse return arrangement. But that also can be something that your geoengineer or someone specifically designing the well system, the bore system can handle. And they all get combined. Now, the combination is a whole separate system about how we work that through with pumping, capacities, temperature monitoring, and all that. But the idea being it's a closed loop. You're sending water out to exchange or absorb heat, and you're bringing it back.
And I think it's safe to say vertical tends to be one of the most common forms of bore field construction, but there are others too. So
Yep,
let's
that's
take a
right.
look at those.
A couple of the others are in the situation where you can't go vertical for various reasons. You can do horizontal, so not nearly as deep. We've seen these up to about 100 feet, but typical is in the like 20 to 60 foot underground range. You can see an example of a directional drilling rig at the top left picture. So you're not going straight down, you're going across. Now, because you're not utilizing the depth and the consistency of heat exchange down deep, you do often get less capacity out of a horizontal bore field. But sometimes it still might be worth it because of the overall benefits of having that type of system.
I believe in this case, they hit an aquifer that they weren't aware of or something like that that prevented them. It was just too soggy for them to be able to go as deep as they would have liked. And
Yep.
to your comment earlier about, picking sites that are not going to be built upon, this is a really common example of an athletic field. They know that that will continue to be that, or a green space. That's another place where we might see a bore field happen.
Yep.
All right, let's talk directional.
Another technology, this was a really interesting presentation where if you don't have a large open field that you can drill in where you would space out these wells, and they're typically spaced anywhere from 15 to 25 feet apart when you're going straight vertical, there's angled options. So you basically start at the same point up at the surface, and by angling out the bores, you still achieve a very high level of heat exchange, but you don't take up as much surface level footprint. Really exciting stuff. Canada's doing a lot of this, and this is a really, really good option in dense areas or where you want to go underneath of existing structures.
Great point. All right, I just want to touch for a moment on seasonality, just to reinforce the concept of the fact that that a geo-exchange bore field can be both a heat source and a heat sink. And this type of graphic can be really helpful to introduce someone to just say how it behaves differently in the different seasons. So in the winter, we are drawing upon the heat that we stored, and in the summer, we are depositing the heat that we have left over from our cooling load. So this is just something that can be in your arsenal as you're looking to describe something to clients.
Yep.
Next, we want to talk a little bit more about that, maybe the cascading and the different times when we're using these different things, which we can see on a load profile. You want to walk us through that?
Yeah, understanding what your client needs is critical to evaluating all these different technologies. On the left, you can see a load profile where obviously the red is when they're heating and the blue is when they're cooling. And it's kind of those tight bands in the middle that really are able to take advantage of both the simultaneous, which would be that heat recovery in the purple, as well as the Geo-Exchange, which is that thin band of lighter red. And so it is a big expense to be able to only use it for a limited capacity over a limited time frame. But that's on the heating side. You can also see the lighter blue in the middle of the chilling side. And it is that balance because depending on the size of the field, how many bores you have, how deep they go, your capacity to exchange heat with that geo-exchange field is limited. And this is really, really critical in how you design the overall system of the capacity and equipment in the plant, because you still have to meet the client's demands across all their seasons, across all their buildings, across all the different environmental conditions that they're going to see. On the right is a similar graph, slightly different though. One thing that this one pulls in is air source heat pumps. Air source heat pumps give you a much wider range of use. And we didn't talk much about them, but we just wanted to show that as a comparison, they are a viable alternative. Now they have some downsides, as in they are not as efficient, but it's just wanted to bring that up as a, all of the above kind of conversation in talking about these tools that we have as consulting engineers to offer our clients and make sure that they're educated on what the pros and cons of each are.
That's great. That's a really important part of the conversation. I've got a couple little things that I want to hit on really quickly, and then we'll get to Q&A. But first off, I just wanted to mention that, these projects are becoming more and more common, especially on higher ed campuses. That's where we see it the most often. This chart is roughly from about 2024, so some minor changes have happened since that time. But it shows all of the institutions that are looking at or have either constructing or have existing or are designing geo-exchange programs. And then the green boxes indicate ones that the RMF team has consulted on in some way. And I can get into more specifics if you have any questions sometime. But as a general rule, Jordan, like in the last 10 years, how have you seen this landscape change from your perspective?
Uh, Having been out of it and back into it, it our clients are much more willing to seriously consider it, and they're showing that by spending money on test wells, test bores. So they are really getting into it, and they have implemented, whether they're pushed upon them or internally relegated, their sustainability, including decarbonization. And geo-exchange is a great, great, great way to meet the sustainability and decarb goals for the very reason that it is electrically generated, is an electrification method, and that it can achieve heating without burning fuel. So that has definitely become more prevalent as our clients become more aware of it. And the next slide will give you a little bit more into that. It's the dollars. So IRA was a big piece of the dollars. Now there's a lot going on. The one big beautiful bill. For
Yeah.
those of you
Yeah.
keeping track, have some updates to this. But there are incentives that are being pushed to get our clients and others to consider these previously inaccessible from a cost perspective technologies into their systems. The cost is significant. Just to put a couple of numbers at it, we're seeing anywhere from about 20,000 to 50,000 per hole. And it's important to caveat that's just the hole and the pipe in the ground and the connected. That's not the site work to put it back to a usable condition afterwards. That's not landscaping. That's not anything about the connection once you hit the heat pump in the plant. So that's just that piece of.
And the thermal distribution upgrade, if you don't have hot water, if you're operating on steam, or at that point, there's a lot of costs. Yes, so it is something that we can't ignore, but there are some ways that campuses have been strategizing how to fund these things. Okay, I think with that, it's time to open it up for some Q&A. Got our first question in from Juan. What type of maintenance issues are associated with bore wells? Do you know yet, Jordan?
I do. It depends who you ask, but fairly minimal. It is a closed loop. Uh, there is a important piece that is the start of the answer to that question. That is the install testing. Keeping the pipes clean when they go in and having a very rigorous testing procedure for pressure and tightness when they are still exposed at each time, like at each well, will dramatically reduce the future maintenance issues. Other than that, it's HDPE. There's not really corrosion, and the people that have them and drill them say once they're in and they're pressure tested and they're circulating, there's almost no maintenance to the wells themselves.
We got one from Jack. Have you seen Geo-Exchange combined with chilled or hot water storage to reduce the peak capacity? That's a great question, Jack.
It is. Thank you, Jack. Absolutely. It's almost critical because when you're and it's critical for a couple reasons. A lot of it has to do with the turn down of the connected heat pump. What we're seeing now in some of the larger heat pumps that can get into the temperature ranges we're looking for hot water, they can only go down to 50%. So if you're using Geo-Exchange to make hot water, and the same goes for chilled water, you want to be able to maximize that, and tanks of water storage are an absolute piece of that. We've seen 60,000 gallon heating water tanks. We've seen being able to dual use a hot water storage tank and a thermal storage tank in one piece of equipment. So totally, storage is a really, really great way to further extend the capacity of a Geo-Exchange heat pump system.
One system that I can think of off the top of my head is the UMass Amherst design has that built into it. So shout out to Bill and the team that works on that. But yeah, it is a very frequent component. Great question, Jack. What's a typical payback? Great question, James. 50 years or never? What do you say, Jordan?
Yeah, I mean, I'd have to see the numbers depending on the installation, but not good.
Not good.
Uh, so it's part of an overall system, and extrapolating the savings into both the heating side and the energy reduction are where you can get some benefit. So it depends what
Kristen
it
is
depends
raising
what.
her hand. I wonder if
Okay,
she has
Kristen, there you go. Kristen, come on
something
in.
to add to the
Right
conversation.
person to answer.
Yeah, I was gonna say when you talk about the payback of geo-exchange systems, it's not really what it's about. It's really that it's coming from campuses who have made a commitment to, in answer to your further question, James, still worse, usually. But it's more that they've made a commitment to decarbonization and they are less interested in payback than they are in that commitment. And so we do want to find them the best option to do that while keeping in mind their cost concerns.
And that's where it's exactly just an option to consider amongst all the others that are presented and available based on a client's physical and financial situation. So
Yeah. So James followed up and asked payback relative to its alternatives. Kristen, I might fall on you on this one, but I would say an air source heat pump is probably a cheaper alternative that does pretty well as well, but it's just less efficient, so you get less out of it.
Yeah, I wouldn't even always say that. Air source heat pumps are getting better and better every day. They're pretty good, especially, I mean, it's harder if you're in a place like Minnesota. But even then they're still actually they're doing pretty good. And like I said, they're getting better and better. So
Yeah.
it's kind of exciting to see it.
Have you seen a payback calculatable on an air source heat pump?
Yeah, I'm sure. That's not how I usually do
fair,
it. We don't usually look at simple payback. We're usually looking at present value, but
yeah, that's fair.
I think that we would probably be more likely to see that on air source heat pumps.
Yeah, great. Well, I think that's about all the time that we have for today, but I want to thank Jordan so much for all of the great thought that you put into this and for sharing the wealth of knowledge that you learned at Expo this year. I think that came into play a lot in this conversation. So thanks so much for your time and effort on that. And thanks everyone for joining and watching. We'll see you next time. Have a great day.